Hi,
Hey, hey,
how's it going?
pretty good. How are you?
I'm doing all right. It's the weekend finally, so
Yeah, fine.
um hey, so have you used this platform before?
Once, yeah.
Okay, so you kind of know how it works.
Yep.
All right, so for me, I generally follow the Google Microsoft style of interview. So it's usually in this case 5 minutes of intro, 35 minutes of technical, 5 minutes for Q&A. So since the intro is all anonymous, we just usually skip right to the technical.
hmm
Um, but I do have a couple questions. What is your primary coding language, or at least what you want to code in for the interview, and what level are you at roughly?
Uh, Python, and I'm already in the loop, or I have loops scheduled for Facebook and Google, coming up in a couple weeks. So,
Awesome. So it's an intern, or is full time out of college, or full time?
full time, I have 5 years of experience.
Okay, great. Um, well, best of luck in those. I might be joining you at the Facebook one here soon.
Nice. Nice.
Um, let's see. Do you have any quick questions before we start?
Uh, no, I guess yeah. Let's go ahead.
Awesome. So I'm gonna start you out with wait. Oh, you switched to two. That was why.
Yeah.
Um, I'm gonna start you out with give me a list of XY coordinates.
Mhm.
Um, one, two, 2, 3, 1, 3, so on, right? And then I'm going to give you, this is 2D plane, it could be 3D, 4D, and so on. I'm going to give you a vertex. So let's say, so points, vertex, which will be the center point. It doesn't have to be 0, 0. Let's give it like 2, 2 right here. Then I'm going to give you K value, which will be the number of points that I want you to return. So let's say 2, right?
Mhm.
Um, I want you to create a function that finds all the closest points around the vertex that's in the point list, um, based on distance.
Mhm. Um. Okay, so in this case, vertex is 2, 2. And k equals 2 indicates the distance, so we want to find like what Cartesian distance.
Yeah, just do like x1 minus x2 squared plus y1 minus y2 squared.
Okay, square root of all, right?
Yeah.
Okay, yeah, sure. So it looks like we're just gonna. I have to say, like, I assume all this fits in memory on one machine, and we're getting kind of like integer inputs or at least numerical inputs. Um,
There'll be numerical, yes.
okay. Um, so
But as
within.
far as being on one machine, for now, yes.
Okay, great. Sounds good. Um, So we're getting these two arguments, and we have a vertex too. So vertex, point, and distance, and then what we're just going to go through all the points and find the
Not
distance. Oh,
not max distance, but how many points to return. So like K.
okay, got it. Case points to return. Okay, cool. And we want to return the two closest.
Let's just do number of points to return, something like that. Um, I'm sorry. What was your last question?
And then we're returning the two closest.
Yes.
Okay, got it. All right. So let's see. The first approach that comes to my mind is we go through each point and we compute the distance to vertex, and then we pick the two closest, which we can do sort of in a running fashion. And then if we do it this way, our time complexity is we look over every single point, um, and so we're like at O of P if P is the number of points. Um, Let me think. Oh, and then points to return. So I guess we have to sort the list too, right? Because that could be
Yes.
arbitrarily.
How are you gonna find the smallest? Because
Mm-hmm.
it's not always going to be two. It could
For
be
sure.
Yeah.
So it looks like we have like kind of like if we have to sort it afterwards, then we're at like n log n for the sorting, um, and then yeah, n for the points, right? So n log n total. Um, so that's sort of a first pass that I think would work. As far as trying to reduce the amount of work we do, um, I think maybe there's a way. I mean, maybe there's a way to not consider certain points if our point list was sorted. Is that something that we can assume, or the points just come in random order?
It's random order.
Okay. So I, yeah, because even if we sorted the points, we're back to that n log n, and then we do some like, divide and conquer, right? Like take off the stuff that's clearly out of range, but we're still back at that original issue. So I think this this approach might be uh, as good as we can do.
Yeah, let's start with that.
Okay.
See what that looks like.
Sure. Distances. So we're just gonna, and are we assuming that it's all? There's no assumption that's 2D, right? It could be like arbitrary dimensions.
Yeah, it could be any number of dimensions.
Okay. So fill that in later. We want to get distance between vertex and P for every point in points. And then we want to return sorted, well, how would we do this? Sorted distances. See, so we need the indexes too, right? So we'll get that, and we'll get the index I for all these, and then we'll return sorted.
Of course, C++ needs to do that, where you can do a for loop like that and just have enumerate.
Oh, I see. Were you saying C++ something?
It needs to do that. It needs to implement that.
Oh yeah, maybe in C++ 20. I don't know.
Yeah, right.
Yeah. So sorted distances, and then we want the first up to points to return. We might have to do this to get it as a list. Okay, and then for getting the distance of arbitrary dimension, what we said we would take the square root of.
Basically, the square root of the sum squared.
Is that only for 2 dimensions, or does that work for higher dimensions too?
I don't know. I assume it's higher, but
Cool. Either way, we have a metric, right? As long as it's consistent.
yeah.
Okay. So we're saying we're summing all of them squared. So square sums squared. I guess it would be a squared plus b squared for a, b, and zip p1, p2. God, I hope that works.
What are you trying to do with that? I don't know what zip is, so.
Oh, I see. If you have 2 arrays of equal length, like it matches them up so that can you see the console?
Yeah, I see it.
If you zip like 1, 2, and 3, 4, you would expect 1, 3, and 2, 4 to be together, right? So it like takes the first. Yeah, so that's what I'm doing there.
Okay.
Yeah, and so by zipping, I have basically the first pair and the second pair together, and then when I say for a, b, I unpack the you know, the tuple, and then I'm saying a squared plus b squared, right? So I'm basically computing a1 squared, a1 plus b1 quantity squared, and then b1 plus b2 quantity squared, and then I'm going to take the square root at the end. Is that correct?
Okay. Yeah.
Yeah. So those are
an interesting way of doing it.
Oh yeah. We can. I mean, this is clearly it's like not optimized for probably execution time either.
Yeah.
So I have a list of the squares, and then we want to sum them. So squared sum squares.
Okay, it was a bit delayed.
And then at the very end, we're gonna return the square root. Is it like math square root or something?
Don't know. I don't really know Python, so.
Oh, okay. I guess that's like the downside of having to like interview all these different people using different languages.
Most of the time we could tell. Yeah, that looks right.
Okay.
Zip is just a new one for me. I've never seen that.
Oh, I see. It's pretty common in like a lot of functional languages, especially.
Yeah. I'm sure I saw it in Haskell.
Oh yeah, I'm almost certain Haskell has zip, although I've never used that myself. Look, I gotta print that, I guess. Yeah, is that like is that 3 squared 9 plus 25 square root 34? No, that's not. Oh, hold on. Squares. 5 and 13.
Okay. Maybe it's squaring each one inside because 1 plus 3.
Oh, you're right.
1 squared plus, yeah.
Yeah, it needs to be a plus b quantity squared, right? Like that.
But that makes sense, right? Because x1 plus x1 minus x2 squared. Yeah, okay.
Yeah. Is that right? So it's a plus b quantity squared for each like a, x, y, and z, et cetera, right?
Pretty sure it was minus. Let me look it up.
Okay. And I think that's what it is in 2 dimensions. In 3, I'm not really sure. It might be like cube and then quantity like cube root maybe.
Oh, so it is for any dimension. It's the sum for one in q1 qi minus pi squared.
Oh, squared. Okay. Wow.
So minus inside.
Oh, okay. Oh wait, sorry. What did you say? Is quantity squared or is it inside? It's a squared and b squared.
No, it'd be like x1 minus y1 squared plus x2 minus y2 squared.
It's a -2. Oh yeah, because it's like the difference and then square to get rid of any negatives. Yeah, that makes sense.
Yes, 4 plus what in that case? Yeah, so it'll be 1 plus 1, so 2 in the square root. Yeah, that's 141.
Okay, cool. And this is something we can unit test too, just that function. Okay, and then moving on to back to within distance. Just try that out. 2, 2. These are the points, and I'll return like the closest one. Oh man, it did something, but it doesn't look right because it's returned. Oh, okay. Right, because the first element is the distance and the second element is the index. So,
right.
Sorted this, and then what we want to return is the actual point, right, or a list of the points. So I guess it'll be points at I for I in or something I in sorted this. We're disregarding the first thing. Great. So we have a list containing 1, 2. If I bump this to 2, it should return 2, 3. Okay, that looks nice.
What about 0?
What's that?
0?
Should I 1 minus 3?
Well, sure, but what I mean is check for 0 elements or -1 elements.
For sure. Let's. So first of all, this isn't defended against like if the dimensions are different, right?
Sure.
I don't. Should we do that?
No, let's just leave it here for this.
Okay. And so we should defend against this being an empty array.
Yep.
What should happen if it says to return 2 things and it can't? Should it throw an exception or should it try to return as much as it can?
It's up to you actually. Either works for me.
I think returning as much as it can sort of makes sense to me. So in this case, it would return empty array because that's as much as it could return. In this case, like if I requested a bunch of stuff, it would only return 3 things. Cool. Let me just make sure that sort is working right. Okay.
What about negative number of points?
Oh, that's a good question. So yeah, if I were to request like -3 points, so in that case, I think I should throw an exception because that seems like a misuse of this API, right? Currently, yeah, it does this weird thing, but
Sounds
I don't.
about right.
Yeah, should we do that?
Yeah.
Sure, you can ask for 0 points to return, I guess. Then we'll raise.
Oh, that's what it is. Someone last night when I was interviewing just did not know how to do exceptions in Python, and I figured it'd be throw, but raises it.
Yeah, it's raise. Let's do that.
It's been a while for Python with me.
Sure, I love interviewing in Python because it's like really concise.
Yeah, so I have a little bit of feedback on that at the end, but all right. So let's make it better. You were right that there is something better, but you didn't figure it out right away. Let's try to figure that out.
Okay. Sure thing. So maybe it would be easier if I reduced it to 1 dimension.
Well, no, but as in to figure it out, or just the whole thing?
Just to figure out the optimization. So in 1 dimension, there's like a single like point, and then there's a bunch of dots scattered upon this number range. And we want to return the n closest things, but the input is not sorted at all. And sorting it would be prohibitively expensive, and these aren't whole numbers or anything that are within a range, so we can't like bucket sort them. So let's see. So doing better would mean like not looking at some of the points, right? I'm assuming.
Yeah, sure, but what if we just stored like k elements instead of n elements in something, or maybe just kept the closest k elements in temporary storage somehow?
Let me think. So you're saying, instead of, okay, I'm wondering what that means because we're getting this list of points, n long, right? And then we need to return k things. And if I could if I could maintain a list of k elements or some collection of k elements, and go through, but I would still have to go through every point, right?
Right, you're still looking at every point, but is there an algorithm where you can do like n log k instead?
I see. Yeah, got it. Yeah, so maybe we can maintain like a min heap of k, and then right, yeah, and then we go through, and then every time we insert into k, if k is pretty small, especially, inserts would be log k, right, into this min heap. Um, Same with removals as we, pop off things at the end.
Mm-hmm.
Uh, and then at the end of it, we just dump out kind of the min heap, I guess. If order doesn't matter, especially.
Sure.
Okay.
Let's do that. Leave the code above though.
Okay. We'll leave the code. Okay. So wait. Um. So I'll just copy. I'll make a copy of this guy then. Uh, so a lot of it stays the same, except I get the distances, and instead of sorting over the entire list of distances, I'm going to iterate through the distances and put them into a min heap. So what is that? It's like import heap q, yeah, heap q dot.
Okay, that's cool. Like whenever I go to just into Python, I've never seen that before.
Yeah, there's a joke that Python has everything, right? So of course it must have.
Right?
What is it called though? Heap. Mind if I look it up real quick?
Yeah, sure. Maybe a priority queue.
I don't know, let's see. Oh my God. Uh, Interesting. Wait a minute. Priority queue. It's like um. What is this? Is this just a bunch of functions?
Maybe should be like a push or something.
Yeah, actually, it might just be like a bunch of functions on and you give it it operates on a list, right? Because a lot of heaps are just arrays underlying. So like heap push is a function, and you give it a list, and then you give it an item like 3.
Wow.
Yeah, this is a little bit not super object oriented, you know. Yeah. Okay. So it like maintains the list in sort of like heap format for you. All right. That's that's like the most annoying thing I've seen so far.
Right?
Python. Yeah. All right. Well, this is this is the path I've chosen. TQ. So we'll instantiate our heap here. This list, and it's going to be k size. And so what we'll do is we'll say for each distance distances. So if for each distance, actually, sorry, it was distance comma index, right?
Do you really want to like generate a whole new list of space?
On which line? 35?
32. Why not just insert the distance as you go?
Oh, yeah, that's true. Okay, we can do that. I mean, if we're getting into this level of optimization, like it's gonna be faster not to just to not do this in Python in the first place, kind of thing.
Yeah, true. But you picked it.
Yeah. So I mean, yeah, maybe I should have asked what kind of thing we're optimizing for. It doesn't change the time complexity. I can do it if it makes the code, if you think it makes the code easier.
Well, not really easier, but let's say we have 4.5 gigabytes of data and 8 gigs of memory. Creating
How would
the
that?
extra distance will be a lot.
We'll use a lazy evaluated generator. Does that your concern? Okay. So
Wait, what?
with that, it's a lazy evaluated generator. So instead of actually materializing this into a list, it will become it becomes a generator, which is like, think of it like an iterator, like in Java.
Yeah. Okay.
It has a next and whatever, and then when you say for something in that, it can materialize that list. So
Cool. That
right.
works then.
Great. So we're here, and then we're gonna look at each distance and index, and then we're gonna add it to the heap, and possibly pop something off if it's too big. And should we pop first or should we add first? I guess it doesn't matter in this case. So let's add first. So we say heap key.heap push. We give h, and then we give the element, which is distance and index. We need both. Right? I'm hoping that the heap will handle tuples. We just use yeah, it does. Okay. Cool. So we heap push, and then if length of heap q. Actually, I wonder if that doesn't even work anymore.
I think
okay,
you type in, right?
Oh yeah, I was just making sure that heap q had a length function. If the length of heap q is greater than k points to return, let's go ahead and was it pop heap? Wait, we need to remove not just the smallest one, right, but the biggest one.
Yep.
Um,
Hey, do you still hear me?
I hear you. Yeah.
Okay, I moved my mic a little bit. My cat decided to she wanted to talk into the mic apparently.
Oh, okay. No worries. Cats will just do that all the time. Good way to pop the weakest one. Is there a way to do that?
Can you maintain some sort of like max heap where the top element is the max?
Let me see. I'm not sure how the like order that it uses in Python. I've like literally never used this class.
Are you looking it up or?
Yeah, I'm looking it up.
Okay.
Interesting. It's called eq.heap_push_pop_h thing. Oh. Okay. Heap push pop? What's that? Oh, interesting. Okay, that's disappointing. So there's a method called heap push pop, which is a little bit, so basically, if there's less than the points to return, we can just insert it directly.
Sure.
Like that, but if it's greater, then it becomes heap push pop. Feels like it was 10 years ago.
Yeah, it's an interesting function. Okay, let's not stop here, but stop on this part. I'm gonna switch it up a little bit. Instead of something that fits in memory, let's change it to, let's say, 500 petabytes of points.
For sure. Okay, so let's say we have just, it's distributed on a bunch of machines, maybe it's like in HDFS, and it looks like we need to, use some sort of distributed computing, and it looks like in this case, the part where we say distances, like on line 16, that get distance thing is, what do they call it, like massively parallelizable. It's like obviously parallelizable. So we do something like MapReduce, right? We compute the distances, right, in our mapper step, and then we emit basically distance, like a tuple of distance comma index, right, or distance comma and the original thing. And then in our reducer phase, we find the smallest. Yeah, so it would end up looking like line 12 basically, if we use something like MapReduce, because we would, basically run 16 distributed in the mapper phase, and then on 17, Hadoop would run a merge sort for us on the entire data, and then we would just return like the smallest, like the head of the file basically in our reducer. So how should we do our reducers? Normally in Hadoop, the reducers get data kind of just, there's like they hash the key, so it ensures something like even distribution, but we don't want that.
Sure.
Maybe what would happen is we could do that, but then each reducer pairs it down to k points, right, which is like kind of the safest thing to do. But we have k points for every reducer, and then maybe we just run the process again, like just we iteratively pair down till we get like k points total. So
makes sense.
Yeah, trying to think if there's a better way to do this. Because we don't want to, especially if case small, we don't want to generate a bunch of stuff for nothing. Yeah, I mean that would be one approach. I wonder if the heap.
Can you write out like a map and reduce then function just to see what it would look like?
Sure. So the map function, given the vertex and some points, would yield basically, we would say we would compute like the distances, right, kind of as before. So we'd be like for points and points. We would be adding to this list like distance and the point itself. So get distance and then p. Point. That, right? So in our mapper stage, we simply, return back, and then we should get like, distance 4, point is like 3, 2, or something like that, right? For one of the entries, etc. And then for reduce, points, we're going to be given the output of mapper output, which is going to be this like list of the mapper output, and then what we want to do is and k, I guess, or like k, and then we'll just like return, I think so. this might be like where MapReduce is sort of limiting, because if we do this, we will get, best case we'll get our answer, but like worst case we'll get like k times the number of or reducers basically.
Yeah.
Alternatively, we can do, well, you can use a single reducer, but it basically never complete. So I don't know if in Hadoop you can have like tiered reducer stages.
I don't think it does yet. Google's Flume, I used to work at Google, is just getting to that point now to where it can have tiers, maps, and reduces. I don't think Hadoop has it yet.
Okay. What about Spark? I know Spark has like a more iterative computational model. Maybe we can model this easier in Spark.
Let's just stop here. It's been nearly 35 minutes, and I have everything I need to do. Sound good though?
Okay.
I kind of want to hear your feedback of yourself first, of how you think you did.
Let's see. I think I might have jumped in a little bit too soon. Just because I produced a suboptimal algorithm initially. I probably should have stepped back and tried to come up with like maybe the heap solution.
Okay.
Yeah, that's sort of my big one.
So, do you want to hear my feedback now, or do you just want to read it later?
I'll hear it now.
Okay. So I'm not sure I agree with that. Because the idea is that you're supposed to come up with a fast, quick solution and then optimize on it. Beforehand, you clarified everything. You got all the edge cases. I wish you would have started by saying, "Hey, here are the edge cases. So let's put in the errors," right?
Mm-hmm.
And then, like, if there was 0 points, you could have just skipped everything and just returned null. If there was more than k, you could have just returned the current points list, or k greater than n, right?
Mm-hmm.
And then gone into it. One thing I wasn't a big fan of, Python list comprehension is really cool. I like it. And like the zip function is really neat and compressed and stuff. You're going to Facebook, you're going to other places that may not get it. I didn't even get it all. So it might be easier to just simply do an if statement for some of them. List comprehension is fairly simple to know, so probably not something that you would need to.
Mm-hmm.
8, I would have definitely expanded to like foreign ifs and stuff like that.
Mm-hmm.
Not ifs, but yeah. Um, definitely a for loop instead. It took you a while to get the heap, but as soon as I asked about an algorithm that might be in log k, you got it right away. Um, code looks good. Pretty. You can tell you're fairly experienced. It follows some sort of like style. Um, Yeah, and then you definitely knew about a MapReduce. In the very beginning, you considered if you needed a MapReduce or if it could fit in memory.
Mm-hmm.
Overall, I'm impressed. You did really well. Um, you're very knowledgeable in everything. You took a hard problem that actually, surprisingly enough, has not been answered correctly. The MapReduce part by anyone that I've ever interviewed until you now.
Uh-huh.
Yeah.
I used to when I first started my career, so might be
What?
a nice. I used to work on Hadoop on
Oh,
a
sweet.
structure team.
Yeah, I'm coming from Google, so you change your entire mentality to go from doing stuff linearly to assuming it will be done in a MapReduce.
For sure.
If you get the job at Facebook, you're probably going to have to do the same, to where everything you write is just map reduce, which is cool. It's a fun thing to do. Probably not the feedback you wanted to hear, because I don't really have much criticism. Like, you did really well. I would have definitely passed you.
Okay.
And probably fought for you to get the job.
Nice. Well, I'm super glad to hear that.
Yeah.
Yeah. I feel like I'm gonna keep the studying up. But it's.
Yeah, you should. I definitely wish you the best of luck. I'm echoing a little bit, but in Facebook, and what was the other company?
Google, actually. So.
Oh, Google. Yeah. Google and Facebook are tough. I didn't do system design, so I don't know how you do with that. If you do another interview, I recommend asking to do system design. And I'll make a recommendation. I didn't see that recommendation, but
yeah, good.
Just to see where you stand with that. But overall, I think you'll do great. Do you have any questions?
I guess, yeah. Just out of curiosity, like, what do you get out of using interviewing.io as an interviewer?
So I created a nonprofit based on kind of giving back. Man, I'm actually a lot over there. But based around giving back to the next class of software engineers. I kind of came from a weird dark background in my history, and I shouldn't be where I am. But because I am, it's like, I want to help other people get faster and be kind of get to that same point. And this interviewing.io is a really solid platform to do it. So it's kind of what I get.
Yeah, no, that's super awesome. I guess I'm very appreciative that you've taken time out of your day to help me.
Yeah.
I guess everyone on the platform.
It's my pleasure. Hopefully one of these days I'll be seeing you on Facebook.
Yeah, that'd be great. Yeah.
Any other questions?
Nope. I think that's it. Thanks a lot again for the interview.
I do have one other thing of feedback.
Yeah.
I would try to find like a quiet room or something where you're not echoing, or where I'm not echoing.
Oh, okay.
Because I can hear my voice really bad.
Oh man. Okay. Whoops. All right. I need to use headphones, I think.
Yeah.
Thanks for the feedback.
No problem. Anyway, wish you the best. I'll fill out some feedback, but it's not going to be much. Like, you did really well, so I don't really have much to give you to get better, since you did phenomenal.
I mean, no, it was just the experience and practice is tremendously helpful, I think. Especially because I like to things up too on interviews. So, thanks a lot, and have a great rest of the weekend.
You too. Thanks.
All right. Bye.
Bye.